Okay, so this is going to be the 10th episode in my ray tracing series in Java. So this episode is going to be more of just me coding. I guess I'll talk a little bit, but this is going to be one of those episodes where I do some dev for about an hour. Probably talk out loud to myself, maybe explain things while I'm doing them. But this is just my approach to how I would organize this ray tracer. Right now it's pretty unreadable. I mean, it is readable, but I don't know. I prefer more objects, more abstraction, so I guess that's what I'm going to go for. Alright, hold on. Let me plug in some music so I can listen. Probably leave one ear out so I can still hear myself talk. Okay, so let's see. I guess the first thing that I want to do is make a world class. So where would that go? Just make a new package and call it scene. I'll add a new class. Actually, let's start with the ViewPlane. ViewPlane. We'll make it 2 words. ViewPlane. Okay, so I guess for the ViewPlane, we want a width and a height for the ViewPlane, and we also want a pixel size. We should swap this. I guess it doesn't really matter for optimization purposes, but you should always put the largest data types first, so you don't have gaps in between. We'll call this size. So I have a pixel size. Let's make this double so I don't have to put it in float every time. This doesn't matter. We have more than enough memory on modern day computers. And I guess a constructor to create the ViewPlane. Double size. Hold on, just give me a second. So we create our ViewPlane, which is our 2-dimensional space in 3D. So it represents our computer screen, which is 2-dimensional space, which will be projected into our 3D world. So all of our rays will be cast out from the ViewPlane and intersect objects in the scene. So I guess that's all we need for now. It's just a constructor. And I guess we can make, I'm lagging here, we can make a world class. I guess, let's see what we want in the world class. We would want a ViewPlane. Call it ViewPlane. What else? An array list. Geometric object. And we'll call this objects. So we can store whatever objects we want in the scene and then loop through them. So let's see, what else we need. I guess for now we could have a background color. Let's call it background. So ViewPlane objects backgrounds. That seems like it for now. We'll just create a default constructor. So make it take in a width and a height and a pixel size. So ViewPlane equals new ViewPlane. We'll pass in width, height, size. Oops, we want this to be a double. I could set our background equal to black, I guess, for now. 0.0f, 0.0f. separate this. Objects equals new array list of geometric objects. Initially make it empty. What's going on here? Cannot be resolved to a type. Oh, it's just geometric object. There we go. And then I guess we could add some objects. Let's do we'll add some spheres. What was a sphere? New point 3D. So we'll do one at the origin. Size 50. I'll make this one red. There we go. Then we could add another one. This time we could have it off to the left a little bit. So we can make them all the same size. New color, we'll make this one green. And then one more, push this one off to the right. And then we'll make this one green. So we have a view plane, set of objects, background color, and just the default constructor for now. When we get into the modeling portion, when we implement lightweight Java gaming library stuff and actually turn this into a real application where we can model something like Blender, we will have to create a default constructor that's a little bit different from this, and then we'll have like add method, so that every time we click like in the user face, let's say we'd have something up here that says add object, and then we'd come down and click like sphere, so we'd add that in. But for now this works. So we have a world and a view plane. Let's go to our main method. Let's make an image class. Put this in utility. So we want our buffered image, buffer, and our file image. So we can make a default constructor. What we want, the name of the file, string file name. Let's see here. So when we create an image, I guess we can name the file. But we also need to create the buffer. This takes width, height, type int RGB. So we need to get the width and height somehow. So that'll be declared. So let's get rid of this. Get rid of this. So when we create our world object, so let's do world equals new world. So this will be 1600, 900, and 1.0. So we can do static world. We can import this. So we create a world, and then we can do public static image. So we can do image equals new image, and then it takes in image.png, so the name of the file. So I guess we can go back here and do driver.world.viewPlane. Jesus, it's a lot of calls. World.viewPlane. I guess it's alright. Yeah, that's fine. And then we'll have a method called write. This will be file type. So we have image io.write buffer file type image. Let's try and catch. It's fine. If we can't write the image, we'll do system.out.println could not write image. We'll do display.destroy. We'll do system.exit1. What can I? Did I not save this? What's going on? Okay, so what can I? What am I thinking? I haven't even implemented lightweight Java gaming library stuff. So we'll just put could not write image and exit. Let's create our world, let's create our image. So down here we could just do image.write png. This is world.viewplane.height. This is world.viewplane.width. So you know where it's coming from. Crap, this is the same. This is image.buffer.setrgb. This is world.viewplane.width. It's a very long line. World.viewplane.height. Let's try this and see if it works. It still works. Okay. So now we can do, I kind of want to throw all this in another method. Let's see. Actually, what we need to do is find throw us in another class. Something like tracer.trace xy. Actually, this would be like tracer.trace. So we'd have like a class called tracer put this? So I could put this in the scene. Or is it a utility? I guess I could put it in the scene. No, we'll just throw it in the main for now. Just call it tracer. So this will be public void trace int x int y. Maybe just throw all that crap in here. Oh, this gets even longer. Driver.world. Let's get rid of all these. We already created our world. Equals new tracer. So let's create the object. This signifies that the ray tracing happens in here for this x and y value, and we write the image. So I guess we can delete some of these imports. Oh, we can delete all these imports except for one. It's a lot cleaner. Let's create a world. The view plane is 1600 by 900, pixel size of 1. Create our image and the name of our image, and then initialize our tracer object. Guess we don't really need to. We can make this a static method. I guess it doesn't matter. We can just create it and then tracer.trace for this x and y. So in here we'd have the method to trace. This would be let's just comment all this out for now. So we'd have, let's say, for int I equals 0, I is less than driver.world.objects.size I++. So we're going to loop through every object. Let's see. So we want the closest object hit. So we're just going to cycle through. Let's see. So I want to create a new array. I mean, it's the same array every time. So we could do ray equals new ray, new point 3D. Let's just try this out for now. X minus driver.world.viewPlane.width divided by 2. Y minus driver.world.viewPlane.height divided by 2 plus 0.5. Forgot about the 0.5 plus 0.5. And then I guess we'll have them all 100 away. Oh my god, this is gonna be new vector 3D 0.0, 0.0, negative 1.0. Oh. So we do if driver.world.objects.getI.hitRay is not equal to 0.0. Color equals so we need a variable. Just have it integer dot we get double dot max value. Is less than min. So if the ray hits the object, which means it's not equal to 0, and the ray that hits the object is closer, color equals driver.world.objects.getI. So I guess we'd have a color. This would initially be the background color, so driver.world.background. Now this is dot color. So for every object that we have in our scene, for this ray that we created, if that ray hits the object and the distance from the ray origin to the object is less than the initial or the previous intersection, set the color to that object's color. I guess we don't need anything else. So we'd have, let's just get rid of all this. So then we have driver dot image dot buffer dot set RGB XY. This would be color dot to integer. So let's try this and see what happens. I feel like it's not gonna work at all. It only showed up one object. Why is that? Let's make these like negative 150. 150. Not sure why this, let's see. Just the one object. Still red. Like I'm missing something here. Image.write PNG. still the same one, so what's going on here? Oh, that's why. No, we're just going to do, so if it intersects, let's just do this up here. Double temp equals driver dot world dot objects dot get I dot hit ray. So now we can do if temp is not equal to 0 and temp is less than min, min equals temp. Okay, now let's try this. Still the one. What's going on here? Okay, now let's try this again. Oh, that's sad. Okay, there we go. Got my 3 objects. Let's add a plane here and see what happens. Add new plane. Can't remember what the point. It's a point. I already imported that. Okay, let's see. So point, we'll just center it the normal color. So new point 3D. Center it at the origin. New normal. Something like that. New color 1.0. Let's try that. Is that upside down? I think it is upside down, so let's see. Driver dot world dot ViewPlane dot height minus y minus 1. That should flip it over. I think that's right. Let's make this smaller. So I guess that would actually be a more Yeah, that's right. Because this normal would be almost vertical. It would almost point all the way in the y direction. So this gives us a very small slant. Obviously it goes all the way up to the top because that's infinity, so it would just keep going forever. And then it's black down here because the plane passes through the view plane. But let's see if we can't implement anti-aliasing now that we have this. So we'd have so this is for each one, but we want so how we do anti-aliasing? So we create an array, but we need multiple arrays. So I guess what we could do is for int row equals 0, row is less than let's see, driver dot, let's make a new class for this dot sampling dot samples. I think that works. And column equals 0, column is less than driver dot sampling dot samples column plus plus. So let's make that class. Let's make a new package column. Call this sampling. Sampler. I guess we can make an abstract class. This will be abstract. So it turns a 2D point, and we'll call this sample. Takes the row, the column, x, and the y value. It's an abstract class. So we want int samples. Public int samples. Oh, this has to be abstract. And then we could have like regular sample. So we could have a constructor that takes in the number of samples. This does extends sampler. To implement that method, public point 2D sample int row int column int x int y. I guess what we basically let's make this the driver class. So public static sampler sampler. So we'd have like sampler equals new regular sampler, regular sample. And we'll do like what, 4? Let's do 8. Why would I not be able to save this? There we go. So now we can take something like point 2D point equals driver dot sampler dot sample with actually this has to go in here. This is sampler so this would be point 2D point equals driver dot sampler dot sample. I'll pass in row column x y. And from there we can make our array. Equals new. I'm just going to copy and paste this. So this will be what is this point on x? Let's see. So make a point, and what will this point return? Point we're sampling, right? I want to make it more abstract than that. This should just be like point dot x, right? And like point dot y. You know? Oh wait, what happened here? Like that. What we do is point 2D point equals new point 2D. This would be x minus driver dot world dot ViewPlane dot width divided by 2. This would be plus. This is regular sampling, so this would be column plus 0.5 divided by samples. Let's make this so point dot x equals x minus driver dot world dot ViewPlane dot width divided by 2 plus column plus 0.5 divided by the number of samples. Then point dot y equals y minus driver dot world dot ViewPlane dot height over 2 plus row plus 0.5 divided by the number of samples. So this would be regular sampling. So we can return the point. Let's split this up. So make our point and return that point. That actually works. And that actually gives us space to do driver.world.viewplane.size. Such a long line. I hate having lines this long. Driver.world.viewplane.size. Actually, I mean, we could abstract this out and make this line shorter by creating a new class. So we could do like ray equals projection dot create ray. Actually, that's a good idea. But we only have one projection type right now, orthographic. I guess we could abstract that out right now. So we could do, let's make a new class, let's make a new class, make a new package, projection. We'll just call this projection. We'll have a base class. So what do you need to know? I'll make this abstract. So every projection type has, I guess we don't need to know anything. We don't need any fields. We'll just worry about the method create ray. Do I need to pass anything in? I guess the point. So a 2D point, 2D point. Return array. So then we can do orthographic. And then we could implement that public ray, create ray, point 2D point. So we could do save this, get rid of that, get rid of that one. We could do like, just copy this whole thing. Driver dot projection dot create ray. And we'll pass in the point. So I'll return a new ray. So static projection. So here we'd have projection equals new orthographic. Oops, I have a driver here. Public. So we can import this. Import this. This actually, I don't think it extends projection. So that looks good. So this will then be, so we could do like ray equals new ray dot origin equals new point 3D. And then we could just copy this whole thing actually. Like that. We don't have a default constructor, do we? Guess we could go and create a default constructor. So this could just be origin equals new point 3D and direction equals new vector 3D. Do it like that. And then just set it ourselves. So ray.origin dot x equals driver dot world dot viewplane dot size times point dot x. And then we do ray dot origin dot y is the viewplane size times the y coordinate, and then we could do ray dot origin dot z is 100. Do ray dot direction x equals 0.0, ray dot direction dot y equals 0.0, negative 1.0. Then we can return this ray. Let's get rid of this. What happened? Close my workspace. Just give it a second while it loads up. Sorry, I haven't been talking very much. Guess I'm just focusing on what's going on. Yeah, but leave comments if you want about my design. It's not the best, I know, but I mean, it's what makes sense to me, and I will come back and try to fix more things as we move on with the series, but for me this makes sense right now. So we would have this up here. So we'd have like the initial world background. Actually, this would be new color 0.0f, 0.0f, 0.0f. So then we have how do we want to do this? We want to do I guess either way we're going to have a for loop. We're going to have 2 embedded for loops instead of another for loop. So we only want to do anti-aliasing if we've actually hit the object. But I just can't determine that until so this is going to need lots of optimization later, this whole area, but let's just, I guess we'll just deal with it for now. So you need to see if this ray hits any object. So double temp equals driver dot world dot objects dot get I dot hit ray. So we'll get the value. So if this is not equal to 0.0 and temp is less than min, actually that's not right. Let's see. We want this up here. We want for so we want to trace all the objects. So let's see. How am I going to do this? Just give me a second. I don't know how we're gonna. Well, let's get rid of this for now. We don't need this. Okay. Let's see. So we need. Let's see. It's not gonna work. Get rid of this one. So we need like a base color. And then like our temp value. Minimum, so this would be like double max value. I guess we could have our for loop inside. So then we could have like double temp equals driver.world.objects.get I. So see if this ray hits this object. So if temp is not equal to 0.0, and temp is less than min, min equals temp. Also do like because we need a temporary color, so color temporary temp color. Do we need to assign this? I guess we could just set this to black. Oops, temp color makes more sense. So do like temp color equals driver.world.objects.getI.color, and then we want the final object. We want the closest object. So I guess once this whole loop is done, we would have the closest object and the color of that object. So we could do like color dot add temp color. And then like color dot divide samples. This is going to be driver dot sampler dot samples times driver dot sampler dot samples. And then we could set that to, I think that works. Oh, I'm scared to try it. So you never really know if it's gonna work. I feel like it's gonna take a long time too. How many samples did I set? 8? Let's do 4. I don't want it to take too long. Actually, it did work. Wow. But what I just realized is I don't want to add just the temp color, so like we need like a variable here, so we'd have boolean hit equals false. So here we'd have hit equals true because it hit an object. So we'd have like if hit is true, and do that, else driver.image.buffer.set RGB. I'll set this to the background color of the world. So let's try this and set the background to what happened here. Oh, dot to integer. There we go. So let's try this again. Let's delete this one. Yeah, that's fine. Still working. So let's change the background color to, what is that, cyan? Is it like a purple color, or is it like a bluish green color? Bluish green color. So I guess it kind of worked. What is this black value here? Should be like driver.world. No, that should be right. Let's see. So the initial color you start off with is black, so the hit is false. So create array, temporary color is black. So if there is a hit, then you can set the temp color to this value, and then add it to this black color. And once all it's accumulated, then you can divide it by the number of samples squared. So if you have a hit, you take that color value. Otherwise, if there's no hit, so why does this image have black in some spots? Shouldn't be like that. Let's go to the plane and see if it does it on the top half. I think it should though. It's a long episode. It's gonna take like 3 hours to upload. Yeah, it's still black in some spots. Should be blue unless the mixture of that green and blue makes black, but it shouldn't. What is this? Let's get the plane back. So let's go back to our tracer. So this is our temporary color. It's black. So for each row and each column in that pixel, create a point, create array. Have a min value, temporary color, cycle through every object. It's not equal to 0, temp is less than min. Min equals temp. It obviously hit an object. So you could do, oh, that's why, let's see. This hit variable doesn't refresh. Let's see. That's why this one should be the background color. Driver.world.background.color. What? No, background is the color. So if there is no hit, then you add the background color to it. Okay, let's try this. I think it should work now. There we go. That's much better. Oh, the anti-aliasing on that blue background is horrible. There we go. So we'll switch this back to black. Let's change this. I think that'll zoom in a lot more. Let's see. Oh, there we go. It's a lot better. Let's make this like 0.3 so that we get all of them in there. Okay, there we go. So let's just go over this real quick. So we have a world object where we store all of our objects, all of our geometry. Then we have an image that we can write to. Tracer object, which calculates basically the algorithm for ray tracing. Sampler, which helps with abstracting the process of anti-aliasing, and then projection. Oh, that's what I forgot too. Jittered sample. So this would be extends the sampler. Public, what does this return? Point 2D, sample, into row, into column, and y in x values. We also need a constructor for this one. Int samples. So this dot samples equals samples, and then random equals new random. This is jittered sampling, so this is the random noise. That's the noise anti-aliasing algorithm. So let's call this random. We'll import this, and then I'm basically just going to copy the regular sample. It's basically the same. The only difference is we use float instead of double. We don't need that much precision. So this, let's Ugh, I keep closing my workspace. So you can see how long this has been running for. An hour. Wow, this is a really long episode. I might split this into 2 videos. You know what? Screw it. I'll just upload it. Anyways. Oh, that's a really long episode. Jesus Christ. Anyways, okay, so I don't think I'm gonna go back and explain all this because basically just ran an hour-long episode of me doing developing, and I didn't really explain much, but I guess I can make another episode explaining this one more thoroughly. But yeah, so I'm just gonna end the episode there. Thanks for watching. It's decently difficult trying to figure all this out in a way that makes sense to me. I guess that's the whole point. You create your program so that it makes sense to you, but is applicable to the user in a way that you can abstract enough so that it makes the developing job easier, as well as allow more readability for when this becomes exponentially more complex. Like when I start implementing modeling, maybe the compositor, rasterization for the modeling aspect, along with linking the 3D view using OpenGL with the ray tracing image and making sure that they match. I'm gonna be glad that I made this extremely readable like I did. So yeah, thanks for watching. I guess in the next episode I'll do some explaining, or maybe I'll move on to projections.